In this video, we will practice our inverse trig relationships. Remember that an inverse trig function is just an angle. It's the angle, for example, the inverse tangent is the angle whose tangent is negative radical 3 over 3. Now, don't forget that radical 3 over 3, it's the same thing as 1 over radical 3, in case you learned it that way. Ignore the negative sign for a minute. Let's remember all of the values that we have memorized. So when I ask you what angle has a tangent of 1 over radical 3, you should be thinking pi over 6. All right, because tangent of pi over 6 is 1 over radical 3. Now that is not going to necessarily be the answer, but that will definitely be the reference angle. So far I know that the reference angle is pi over 6. So consider a small diagram of pi over 6's. All right, here's what a diagram of pi over 6's would look like. Oh, I messed it up. Okay, not the best drawing in the world, but something like this. Now, there are 4 angles that have a reference angle of pi over 6. And let's see, tangent, we're talking about tangent. Tangent is positive here and here. Tangent is negative here and here. These are the 4 angles that have a reference angle of pi over 6. Now, we want the tangent to be negative, so right away we're going to forget about this angle and this angle. So it's down to these 2. But we also must consider that the inverse tangent is restricted to only the right side of the unit circle. So with that in mind, then I can forget about this one that's on the left, and this one has to be the answer. This is negative pi over 6. All right, I cannot call it 11 pi over 6 because that takes me outside of the restricted range of the inverse tangent function. I can't go out here. All right, moving on. Number 2, arctangent is the same thing as inverse tangent. So arctangent is just an angle. It's the angle whose tangent is negative radical 3. Forget about the negative for a second. What angle has a tangent of radical 3? Well, that's one of those things we should have memorized. Pi over 3. Tangent of pi over 3 is radical 3. That tells me the reference angle for sure. So the reference angle is pi over 3. Now let's consider a diagram. All right, here's a diagram of pi over 3's. There are 4 angles where the reference angle is pi over 3. Tangent is positive here and here. Tangent is negative here and here. Those are the 4 reference angles, the 4 angles that have a reference angle of pi over 3. Now we want a negative tangent, so we can forget about these 2. We also know that inverse tangent is restricted to the right side of the circle. So we can forget about this one. Okay, this is negative pi over 3. We cannot call it 5 pi over 3 because going this way takes us outside of the restricted range for tangent. We cannot go out here. We have to, if we just go straight down, we're staying within the restricted range. All right, number 3. Arcsine. Arcsine is just an angle. It's the angle whose sine is 1/2. Well, that is pi over 6. That's just, we've memorized that, and that's all there is to it. Number 4. Inverse cosine is just an angle. It's the angle whose cosine is 0. So what angle has a cosine of 0? Remembering that cosine is the x-coordinate on the unit circle, there are two places that have an x value of 0, here and here. Okay, the x value is 0 here, and it's also 0 here. However, looking at the restricted range for inverse cosine, we have to stay in the top half of the circle. So we can forget about this one down here. So that's why the answer is going to be pi over 2. All right, number 5. Arctangent is the same as inverse tangent. This is just an angle. It's the angle whose tangent is radical 3 over 3. Now this is the same thing as 1 over radical 3. And we have memorized that this is pi over 6. Okay, because the tangent of pi over 6 is radical 3 over 3. All right, that's it. That one was straightforward. Inverse sine is just an angle. The inverse sine of negative radical 2 over 2 is the angle whose sine is negative radical 2 over 2. Ignoring the negative sign for a minute, what angle has a sine of radical 2 over 2? Well, that would be pi over 4. That tells us that pi over 4 is the reference angle that we're dealing with. Okay, to figure out what the actual angle is, I find it helpful to draw a little diagram. All right, these are pi over 4s. There are 4 angles that have a reference angle of pi over 4. Sine is positive here and here. Sine is negative here and here. Those are the 4 angles who have a reference angle of pi over 4. Now we want a negative sine, so that means we can forget about these two. But also, inverse sine is restricted to the right side of the unit circle. All right, so we have to stay over here. So that means we can forget about this one. So this is the only answer. And that answer is negative pi over 4. We cannot call this 7 pi over 4 because that takes me into the restricted range. All right, number 7. Arc cosine of negative 1/2 is just an angle. It's the angle whose cosine is negative 1/2. Well, forget the negative sign for a second. What angle has a cosine of positive 1/2? Hopefully you have memorized that that is pi over 3. All right, that's on the chart. The cosine of pi over 3 is 1/2. Now that's positive 1/2, so this is not going to be the answer. This is just the reference angle. All right, but knowing that that is the reference angle helps me visualize what's happening. So here's a diagram of pi over 3s. There are 4 angles that have a reference angle of pi over 3. Cosine is positive on the right-hand side and negative on the left. Those are the 4 angles with a reference angle of pi over 3. We want a negative cosine, so we can throw out these 2 possibilities. Also, inverse cosine is restricted to the top half of the unit circle. So we can throw out this possibility. That means this is the answer. The answer is 2 pi over 3. Okay, look at number 8. Arc cosine of negative radical 3 over 2. This is just an angle. It's the angle whose cosine is negative radical 3 over 2. Forget the negative sign for a second. The cosine of what angle is radical 3 over 2? I'm hoping that you've memorized that that is pi over 6. That's not the final answer. That is just the reference angle. So that helps me know what to draw, though. So I'm going to draw a quick sketch of pi over 6s. All right, those are my pi over 6s. There are four angles with a reference angle of pi over 6. Cosine is positive on the right and negative on the left. Those are the four angles that have a reference angle of pi over 6. I want a negative cosine, so I can forget about these two. Uh-oh. Erased too much. Okay, so these are the negative options. But also, cosine, inverse cosine, is only allowed to be in the top half of the unit circle. So I can forget about this one down here at the bottom. So this is the only answer, and this is 1, 2, 3, 4, 5 pi over 6. Okay, number 9. Inverse sine of negative 1. This is the angle whose sine is negative 1. So what's that going to be? So looking at a diagram, looking for the angle that has a sine of negative 1. Well, on the unit circle, the sine is the y value. So where is the y value negative 1? Down here. This is 0, comma, negative 1. This is the only place where the y value is negative 1. Okay, now am I going to call this 3 pi over 2 or negative pi over 2? I have to call this negative pi over 2 because of the restrictions. Inverse sine has to stay on the right-hand side of the circle. If I say 3 pi over 2, I am going outside of the restricted range in order to get there. Can't do that. Number 10. Inverse tangent of negative 1 is simply the angle whose tangent is negative 1. Forget the negative sign for a second. What angle has a tangent of positive 1? I'm hoping that you've memorized that that is pi over 4. All right, it's on the chart. Tangent of pi over 4 is 1. That's not going to be the answer, because that would give us positive 1. But this is the reference angle. Okay, so I'm dealing with a reference angle of pi over 4. Take a look at a diagram. All right, here's a diagram of a bunch of pi's over 4. There are four angles that have a reference angle of pi over 4. The tangent is positive here and here. Tangent is negative here and here. Those are the four angles that have a reference angle of pi over 4. Now I want a negative tangent, so I can forget about these two. Then I look at the restrictions. Inverse tangent has a restricted range on the right side of the unit circle. So with that in mind, I can forget about the one on the left side of the unit circle. So this is the only answer. All right, and I will call this negative pi over 4. I cannot call this 7 pi over 4 because that would take me outside of the restricted range. Okay, number 11. When you have a function inside of a function, I recommend that you evaluate the one on the inside first and then do the one on the outside. So, the inverse cosine of 1/2. This is just an angle. It's the angle whose cosine is 1/2. Hopefully you have memorized that that is pi over 3. All right, because the cosine of pi over 3 is 1/2. So that means I have to do the tangent of pi over 3. Again, I'm hoping that you have memorized that that is going to be simply radical 3. Boom, there it is. All right, so that's the answer for number 11. Okay, what about the sine of 5 pi over 2? Well, this is a quadrantal angle, so let's look at a diagram. 5 pi over 2. This is 1, 2, 3, 4. 5 pi over 2 would be right here. This is the point 0, comma 1. The sine is the y value. So that means this is 1. So that means I have the inverse tangent of 1. Inverse tangent is just an angle. It's the angle whose tangent is 1. And hopefully you've memorized that that is simply pi over 4. Okay. Number 13. This is interesting. I see that we have inverse tangent of a tangent. Sometimes these will cancel each other out and just leave the angle that's on the inside, but only if it's in the within the range restriction. So 7 pi over 6, let's look at those restrictions. 6 pi over 6 would be right here at pi. 7 pi over 6 would be in the third quadrant. That is well outside of the restricted range for inverse tangent. So the answer cannot be 7 pi over 6. So we can't just cancel these out. So we'll just have to do this the way we did all the other problems. So what is the tangent of 7 pi over 6? Well, here's a quick diagram of pi over 6's. So look, the reference angle is clearly pi over 6. The tangent of pi over 6 is 1 over radical 3, also known as radical 3 over 3. So the only question is, should this be positive or negative? Okay, 1, 2, 3, 4, 5, 6, 7. This is 7 pi over 6 right here. Tangent is positive in this quadrant and this quadrant. So this will be positive, so I'll just leave it 1 over radical 3. So now I'm asking myself for the inverse tangent of 1 over radical 3. This is just an angle. What angle has a tangent of 1 over radical 3? Well, we have memorized that that is pi over 6. Okay, because the tangent of pi over 6 is 1 over radical 3. Number 14. The sine of negative pi over 3. We've memorized that the sine of pi over 3 is radical 3 over 2. What about negative pi over 3, though? All right, this is a diagram of pi over 3's. Negative pi over 3 would be right here. Sine, being a y value, is negative below the x-axis. So this should be negative. So now I've got the inverse cosine of negative radical 3 over 2. Well, this is just an angle. It's the angle whose cosine is negative radical 3 over 2. Forget about the negative sign for a second. What angle has a cosine of radical 3 over 2? Well, that's pi over 6. All right, the cosine of pi over 6 is radical 3 over 2. So that tells me the reference angle that I'm looking at. So I'm going to just draw another diagram real quick. All right, if the reference angle is pi over 6, that's why I'm going to draw some pi over 6's real quick. Okay. There are 4 angles that have a reference angle of pi over 6. Cosine is positive here and here, and no, that's blah, messing that up. Cosine, being the x value, is positive on the right-hand side and negative on the left-hand side. Okay, these are the 4 angles that have a reference angle of pi over 6. Since we want a negative cosine, we can forget about these two. But also we have these restrictions. Inverse cosine can only fall on the top half of the circle. So it can only be in the top half, so I can forget about this one. So this angle right here is going to be the answer, and that is 5 pi over 6. All right, that's the answer, number 14. Okay, this video is getting long, man. There's a bunch of these. Okay, arc cosine is just an angle. It's the angle whose cosine is negative 1/2. Well, forget the negative for a second. The angle whose cosine is 1/2 is pi over 3. That tells me that pi over 3 is the reference angle. Okay, so these are the four angles with a reference angle of pi over 3. We want it to be negative though, and cosine is positive on the right, negative on the left. But inverse cosine is restricted to the top half only. Okay, so I can forget about these. If I want it to be negative, I can forget about this one. So this is 2 pi over 3. So now I have the sine of 2 pi over 3. Well, what's the sine of pi over 3? Sine of pi over 3 is radical 3 over 2. So the only question is, should it be negative? 2 pi over 3, again, is right here. This is where 2 pi over 3 is. Sine is positive here because it's above the x-axis, it's a y value. So the answer is radical 3 over 2. Okay. Inverse tangent of negative 1 is just an angle. What angle has a tangent of negative 1? Well, forget the negative for a second. What angle has a tangent of 1? That is pi over 4. That tells me the reference angle. All right, the reference angle is pi over 4. Let's look at a diagram. Okay, tangent is positive here and here, negative here and here. We want it to be negative, so we can forget about these two. Tangent is restricted to the right-hand side, so we can forget about this one. So this is the answer, negative pi over 4. Okay, that means inside of here we have negative pi over 4. And now we need to find the cosine of that. Well, what's the cosine of pi over 4? That is 1 over radical 2, also known as radical 2 over 2. So what about negative pi over 4? All right, negative pi over 4 is right here. But cosine is positive here. Cosine is an x value. This is on the right-hand side. So this is going to be positive. So I'm just going to leave it positive. All right, now these are opposites. They're inverses of each other. Inverse sine and sine. Sometimes these cancel each other out, but only if this is within the restricted range. 11 pi over 3 is far outside of the restricted range, so we're going to have to do it. What is the sine of pi over 3? That is radical 3 over 2. That's something that you just should have memorized. All right, sine of pi over 3, radical 3 over 2. What about 11 pi over 3, though? Should it be negative? So here's a diagram of pi over 3s. Okay, So if I go around once, that's 6 pi over 3. If I go around again, that's 12 pi over 3. So 11 pi over 3 is just one less than that. This is 11 pi over 3. So sine is negative down here, below the x-axis. So I'm going to have to put a negative on this. So that was the inner part. Now I need to do the inverse sine of this. Inverse sine is just an angle. It's the angle whose sine is negative radical 3 over 2. Forget about the negative sign. What angle has a sine of radical 3 over 2? Well, that's pi over 3. That tells us the reference angle is pi over 3. That's great because I already have a diagram of that. Now, looking at these reference angles, and we're dealing with the sine function. Sine is positive here, and it is negative here and here. We want one of the negative ones, so we can forget about these two. And we want to respect the restricted range, so we're going to stay on the right-hand side. So we can forget about this one. So this is the answer right here. This is the angle that we're looking for. We have to call it negative pi over 3. Okay, going at it this way. We cannot call it 5 pi over 3 because that takes us outside of the range, the restricted range. Okay? Arc cosine of 1/2. That's just an angle. What angle has a cosine of 1/2? Well, that is pi over 3. All right? We should have just memorized that. Cosine of pi over 3 is 1/2. So that leaves us with the sine of pi over 3. That's also something that we've memorized. That is radical 3 over 2. Right? Sine of pi over 3, radical 3 over 2. You just have to have that memorized. Okay, number 19. The cosine of negative 3 pi over 2. What's that? Well, this is going to be a quadrantal angle. Negative 3 pi over 2. So I'm going in this direction. So I'm going like this. All right, so negative 3 pi over 2 is going to land right here. The cosine is the x value. This is 0, comma 1. So the cosine is 0. So boom, that gives me 0. So now I've got to do the inverse tangent of 0. This is just an angle. What angle has a tangent of 0? Well, let's see. What about this angle right here? Tangent is y over x. That would be 1 over 0. That would be undefined. So that's no good. Okay, now I really need to respect the restrictions, right? Inverse tangent is only allowed to be on the right-hand side of the circle. So I'm messing with these values over here only. Okay, so what about this point right here? This is the point 1 comma 0. So tangent is y over x. 0 over 1 is 0. So this is it. This is going to be the answer. This is angle 0. So the answer is 0. Last one. The sine of negative 7 pi over 6. The reference angle is definitely pi over 6. So what is the sine of pi over 6? That is 1/2. Okay, well what about negative 7 pi over 6? Because maybe this should be negative 1/2. I'm not sure yet. Let's look at a diagram. Okay, a diagram of pi over 6's. Okay, negative 7 pi over 6. All right, so this is negative 6, 7. That's negative 7 pi over 6. It's right here. Sine is positive in this quadrant because it's a y value. So now I have the inverse sine of 1/2. This is just an angle. What angle has a sine of 1/2? Well, that is simply pi over 6. That's one of the values that we memorized. The sine of pi over 6 is 1/2. Okay, that is plenty enough for this video. I hope it was helpful. I will see you on the next video.